Okay, so we're going to do mediation. Mediation makes the most sense to do after hierarchical regression. Although it's not quite a hierarchical regression, it has the same feel to it because it is in steps. And what we're going to do is the Barron and Kinney steps on understanding mediation. But essentially, mediation is trying to find suppression, in a sense. There are lots of different modifications for this. There's lots of stuff in the world that will let you do mediation. So we're going to do the simple version. So what is required is first you have to show that X predicts Y. So in our particular example, we're going to show, and we're using categorical variables because I'm trying to get you guys used to them. Our X variable is going to be league. I know. We have to show that it predicts our DV, which is budget. Okay. Or no, I'm sorry, that's our moderator. So pitching relief. All about the pitching. So how many innings did they need pitching relief? I took this data set from an example, and the actual example is at the very end in the write-up. And so the numbers may not make perfect sense, but it was like the example was dumb. So I just made it about baseball because why not? So we're looking at, this is going to be the C path. If X doesn't predict Y, it's kind of hard to say that X predicts M, that predicts Y. So we need X to predict Y for mediation to happen because we're trying to show that this is not the only thing. So we're talking about the third variable problem. If X and Y are unrelated, you're talking about 1 leads to 2 leads to 3, but 1 and 3 are never related. So it's kind of a different question if X and Y are not related. Then I need to show that X predicts the mediator, which in this case is budget. So we expect the leagues to have different pitching relief needs because one league is better at pitching than another. We should probably expect that they have different budgets. And that is the A path. Why are these not in alphabetical? Or I don't know, they aren't. So X has to predict the mediator. So we're trying to show that the relationship from X to Y happens, but when we throw M in the equation, it changes. So it's X, Y. The last two steps go together. It's the same regression analysis. So there's one analysis for 3 and 4, but I need B to predict, the mediator to predict Y, M to predict Y. So if I have different budgets, that will allow me to have different amounts of pitching relief. Right? We have more money, we can hire more pitchers. Or whatever they do with all their money. We did X to M, which is the A path, M to Y, which is B. And then lastly, we want to show that X does not predict Y, which is C prime. So when we put M in the equation, we want C to disappear. And by that I mean we want C to get closer to 0. So we're going to talk about what happens when C is bigger than C prime. So essentially you want C prime to be larger than C in the absolute value, or C should be closer to 0. So if it's negative, C prime should be closer to 0. I did that backwards. C should be bigger than C prime. So essentially what happens is it's all about these two paths being different, but the way we test that is by testing A and B. So we're going to use data set 6. We're going to try this with a baseball example. So does the budget for pitchers mediate the relationship between league and relief? Okay. This originally was an example about housing or something. So for power, this is sort of a controversial subject. Did a little bit of Googling, and the answer is, oh my God, I don't want to look at those equations. So you do want X to predict Y originally, but later you don't. And so it's kind of hard because one time you want it to be significant, and one time you don't. And I also want X to predict M, but those are two different equations. They have different dVs, different IVs. So how do we do this? There are some R plugins, but they're like brain surgery and a half. So what I was going to suggest is try estimating for the final step, where I'm looking at X and M together. Okay. And so that is how this G power is written. Okay. It is different than the other two regression ones. So we're going to try a t-test as our test family. So under test family, pick T. That's what it starts with. And then linear, multiple regression, fixed model, single regression coefficient. Because we're interested in the significant one to be B is kind of the final one. So fixed model, single regression coefficient. Be sure you click 2 tails. Bless you. Hit determine. That's the same, direct. In this example, I did a medium effect size because I'm not very creative. 0.09. Okay. Alpha is 0.05, power is 0.8. Okay. And the number of predictors depends on the step. If you're looking at X to Y, it's 1. If you're looking at X to M, it's 1. If you're looking at M and X to Y, it's 2. So what you'd want to do is pick the one with the lowest effect size. So whichever path you think is going to have the smallest effect, except C prime, because you want that to be non-existent. So don't estimate power for a nothing effect, because you'll get 6,000 people. Okay. Pick the one you think will have the smallest effect. Likely it's going to be M, this B path, because it also includes X in the equation. And estimate that. That will tell you the largest number of people you need. It's kind of probably the easiest way to estimate for mediation. So I have 2 predictors, because I have X and M. And that'll give us 82 people, because it's approximately the same as using the other type of estimator we've used. So, we found 82 before with 2 effects, 2 predictors, and a medium effect, so we found it again. All right. So that is not necessarily the way everyone would suggest doing it, but it's probably the simplest way to estimate for mediation. All right. Now a lot of this, oh my gosh, it is not changed. So we're just going to kind of run through to get to the part that has changed. So for accuracy, we want to make sure it's factored. Yes, it's factored. I have a note in there. I know there are not that many teams, but we're testing across years. Innings can be negative. That's probably awesome, but they can't. All right, the budget can be negative. So we're pretty good. We're running the final model. So the final model has both variables in it. It's actually a really simple MLR with just M and X predicting Y. So that'll be your last model, which you'll see when we get down to running the models. You'll notice I skipped additivity. Well, there's no missing data, 1. And we're going to skip additivity here in a minute. But let's do outliers first. Sorry, I got excited. So for Multilevel, I dropped league because it's categorical. We've got 2 predictors, and so that makes the cutoff score of 1382. And we have 1 outlier. And it's probably because of the budget relief combination. It's probably weird. For leverage, I have 2 predictors in the final step, league and budget. Run through all this. We have no outliers. Woo! And then for cooks, there are 4. And so we add them up, print them out. We got 1 who has at least 2. So whoever that Mahalanobis outlier was also a Cook's outlier, so they're going to get ditched. The other 3 are okay. So we're rerunning that analysis. I've just changed data set names. Okay. And then this is where I basically say, hey, I'm going to skip additivity. Why am I going to skip additivity? Well, that's the point. The point is that x is correlated with y, x is correlated with m, but m is correlated with y, but x and m overlap in their correlation. Because we're trying to get m to basically suppress x out. That's what mediation is about. So if they're really highly correlated, that's kind of the point. So you don't want to actually run an additivity analysis, because then you'd be like, well, they're too correlated, I can't do this. And you're like, wait, that's the point of this analysis. Okay, so don't do it. The only time you would do it is if you have other control variables. So you're looking at this relationship controlling for blah, blah, blah. Then you would probably want to check to make sure your control variables aren't too correlated. If you're doing a traditional 3-variable mediation, you don't run it. It just totes what we're doing. So we're going to skip it. So all this hasn't changed either, so let's just look at our pretty pictures. Yeah. Not so hot. Definitely skewed. Okay. So it's all below 0. I don't know why. So we've got a positive skew. Remember, that's where the tail is. I have at least 30 people, so I'm not too worried about it, but this is skewed. This is skewed and not linear. So these little scallops aren't good. This is real data, if you can't tell. Real data I got from a book. So. And then even better is this weird picture. Homogeneity is probably okay. I got 1 to 1s. It's kind of 1 to 3, so maybe not so great. But homoskedasticity is not good. Right? Because it dips in and then spreads out. That's like the poster child for bad homoskedasticity. So when it comes together and then spreads back out, that's the cheerleader megaphone effect. That's not good. Okay. So overall, this data is kind of bad. So if I were really doing this analysis, I'd probably try and figure out a way to do non-parametric mediation, but that's not the point of today, so we're just going to pretend like we didn't see any of this. I don't know. Mediation is hard to make up data for, so I have stuff from the book that I got this from. And it's an ugly analysis. But it runs and it works, so we're going with it. Here's the part that differs. So we've got to run 3 different regressions. It's 4 steps, but 3 regressions. This is the same regression. And we're going to test first is, does X predict Y? So we're doing a C path first. I'm going to erase some of this so I have room to write. But first thing we're going to do, does league predict pitching? So that's C. So we're going to have a model summary for each one. Summary. And then coefficients for each one. Coefs. So in this guides that I wrote, I put them in as X and Y, but remember they've got to be written as like data set $, column name. It's just which one am I doing here, so I'm going X to Y in this first one. And then get a summary of the model. So that's what I have over here. Okay. Or they just have to be column name because you have the data set name. Okay. So X predicting Y. And this gets confusing when you get to the next step because X predicts M, so the DV changes, not the IB. I'm calling this model C because it is path C. So, does X predict Y? Yes, because this is an example. So our B value is negative 6.77. We're going to talk about how to interpret these in a minute. But I would say that league, negative 6.77. Remember, our T value is going to have 106 degrees of freedom. P is 0.00. If I don't round up. I would also say yes, the overall model is significant. Oops, 106. The problem with having both of these is it's a bit redundant. But the good thing is you get R squared, I guess. 1.0. So this is a T value. There's one predictor. Remember that with one predictor, correlation and regression are the same thing. So this is actually just the correlation between X and Y. So having both of them is a bit redundant. That's why P is the same. But I think having the R squared is what people like. I always give them more information than they might want, because you can always take it out, but you look like a fool if you leave it out. So we're going to include both. All right, so it does predict. Then we would move on to the A path. Budget. Spelled correctly. And so does league predict budget? You'll notice the variables have changed. I'm not adding anything at this point. Like I said, it's not a hierarchical regression, but it's it has that feel because we're doing steps. So let's do model A. So here's the output I should get. If you forget which model you're looking at, well, that's why I called it A. So I know this is the A path, but it gives you the code here that you ran. So lead to budget. So I got negative 2.11. So this is still the coefficient for league. Still 106 here. So negative 3.22. And our model summary for the second one, 10.37. And the R squared is to me, the more interesting part, 0.09. So we got a small effect here and a medium effect here. It's pretty close to medium. So they're about the same effect when league is predicting Y or league is predicting budget. So maybe it's because league actually predicts budget, which predicts Y. So this also would help me if I was wanting to do power. Right? So I would know this one's actually smaller at the moment. Last step is X and M together predicting Y. So we're going to use league and budget to predict Y, because it's like league predicting budget, which predicts Y, so we're doing both of them together. If you ignore this path, we're doing these two lines. So you don't do M only to Y and then X to Y again. Okay, so we've got to do M predicting Y, controlling for X is what's going on. So switch DVs back to innings. So it's model C and X and M together. One thing that people do sometimes when they're just typing this up is they do league and budget predicting budget because they copy the line above it. You can't use an IV to predict itself. It will give you an error. So I've got X and M together. Calling this model B. Now it should give you both coefficients, which is good. This is B and C prime, but let's look at B first. So that's budget here. It's positive. So So the more money you have, the more pitching relief you can have. So B equals 1.56. T is 105 for this last step, because now I got two variables. Where am I? 4.64. P is less than 0.001. That overall model is significant. 15.22. P is less than R squared is pretty big. 0.22. So we underestimated, but by estimating estimating at a 0.09, we probably estimated more people than we needed. But if I was to do this again, I would use this path as my estimator, because it's the smaller one. Now, what happens to league? This is where it gets tricky. You don't want this to be significant. That's a little weird. That's probably the first time all year, except for assumptions. But we don't want this to be significant. So the coefficient, again, is league. So there's a lot of league coefficients here. 3, 4, 7. Let's see. 105. Negative 146. Yay! Seven. So you don't want this to be significant. Because what the point of mediation is to show it's not league to pitching. That's not what's really going on. It's league to budget to pitching. So we're showing that the path is diverted. So you can think about this as, I think about this as the third wheel problem. So it's not really that these two things are related. It's because we have this third variable in there that we're not measuring. We talked about it last time as being like a detour. So we're trying to show that the relationship isn't actually x to y. It's x to m to y. Okay, so it's about the path. On Monday, we'll talk about moderation, which is about interactions. Okay, so in a perfect world, that never happens, except in examples, this is non-significant. Yeah?
So that last step, that's showing that budget is suppressing league?
Yes. Yeah, or mediating. Suppressing sounds bad. Mediating sounds better. Right? But it's essentially what you're testing for, suppression. Yeah. Okay, in a perfect world, this is non-significant, but that doesn't always happen. Sometimes it is still significant, but maybe it's lessened. Some people call that partial mediation. I think there's a movement to just drop the word full and partial mediation, so we're just going to talk about mediation in general. If C prime is significant, we want to test if C and C prime are different. So they could both be significant. This is a fairly big number, but different from each other. Okay, so we're testing if C and C prime are different. Okay, we're going to use the Sobel test. Where do I have the thing about X? Yeah, here. Okay, so what Sobel does is it tells me if C and C prime are different by testing A and B, which is a little odd, but that's the way it works. Okay. It could be that X predicts Y, X predicts M, M predicts Y, but C and C prime aren't different. That just implies they're all correlated with each other. Okay. If C, this one's C, let me just mark it. If when you add M, C gets bigger, so if C prime is larger than C, so adding the mediator made the relationship stronger, that is probably moderation. Okay, so that's a good clue that you don't have mediation, you actually have interactions. And that will happen. You'll throw in M and you expect C to go down, and it gets bigger, and you're like, wait. Okay. And by bigger, I mean further away from 0. So in a negative sense, it would be like negative 10 instead. So if you're trying mediation and C prime gets bigger, switch to moderation. Okay. Okay. So we're going to use the Sobel test to show that these two things are different. Okay. And so you actually do have to have a new package. It's multilevel. So I'll give you a second to install multilevel. There are a couple packages that'll run mediation, but they are obtuse. Oh my god. So I went with, let's just run it. It's by hand is easier. Now the packages for moderation are cute, so we're going to go with this. Any Kansas fans? Kansas? No? Oh, one of them's called Rock Chalk. Every time I see it, I laugh. I'm like, I know where you work. All right, once you get that installed and the library loaded, the code is Sobel. Here, I have it blown up a little bigger. Or I thought I did. Yeah. Sobel x, m, y. However, it doesn't have a data command, so you have to use the $ stuff. Okay. So league, innings, budget, so x, m, y. If you put them in the wrong order, you will get the wrong answer.
Isn't that the wrong order?
Huh? League.
X, Y, M. Yeah.
Oh. X, M. Oh crap, did I do it wrong? X, M, Y. X, M. Oh. So that output that you have is wrong. Why didn't I notice that? Meh. They are in the wrong order. Thank you. Derp. Yeah, that definitely makes all of this wrong. Let's take that out. Don't do them in the wrong order like I did. All right. So let's run this, and I will update the notes as soon as class is over. Okay. Wait. Yes. X, M, Y. Okay. Yeah. Let's make sure we get the right answers. So the first thing you'll get is the C path. Okay, let's make sure it's the same number, 6.77. Good. So it shows me that I ran that first step right, but it doesn't give you a model summary. So that's why we didn't just use this. Next thing it'll give you is actually B and C prime. Okay. So it gave me 3.47, cool, and it's called mediator in here, 1.56, so here. Last thing it shows you, stupid and noise, is the A path, so x to m, so 2.11. Okay. Now this is correct. And then the part we're really interested in is down here under indirect effect. Which we're going to fix everything on the fly here. Okay, so this is the Sobel test here. So the indirect effect part is just C minus C prime. Okay, so it changed 3.3 points. Okay. It gives me the standard error of the change between the two. My z-score, this is actually a z-score, and n. Okay, so z should have been 2.665. Try again. Okay. So it's calculating z by taking the difference between c and c prime, dividing by standard error, but it doesn't give you p. Right. So we want to calculate our p-value by using Pnorm. So what I did was I saved it. Be sure you switch budget and ending since I did that wrong. So I've got saved, and then you can use this Pnorm line. So when I save it, it allows me to put the z-value in so I don't have to change it manually. Lower tail, it's true, times 2, because it's a two-tailed test. So we have to multiply by 2. That gives me 0.008. So let me fix that in here. Okay. So there was a significant mediation, and apparently if you switch these two, it's also significant. It wasn't even late. Normally my excuse is that it's 2 in the morning, 6 in the evening, so yes, mediation is significant. So if this hadn't been significant, we would still argue that there was a significant drop in C. Okay. So significant mediation occurred by including budget between league and innings. Let's do this way. Now, to interpret that, since we have categorical predictors, and that's about to be on the assignment we're going to talk about here in a second, I went ahead and just was like, remember, here's how you interpret categorical predictors. So when we're talking about league predicting pitching, and I have this -6 relationship, what does that mean? So I just calculated the means for league as the IV and innings as the DV. And what you get is there's a 6-point difference between the two in innings. Okay, so the AL is requiring more relief innings than the NL, which isn't too surprising since the NL has statistically better pitching. Okay, so they're one and done faster. Okay. Then I wanted to look at league to budget. So I did T-apply again. And the AL has a bigger budget for it, okay, which is probably a little biased, since that includes both the Red Sox and the Yankees, okay, who have big budgets. I tried to see if there was a balancing between the two, but not really. And even if you think about the Cardinals, it does not even. So remember, just run T-apply to understand what those predictors mean, because it's just the mean difference. When I'm thinking about budget predicting innings, this one here, that is continuous. So as budget increases, I have more pitching relief innings, maybe because I can afford it. And then when we put in budget, this goes down. So really it's about one league has a higher budget, and that higher budget allows me to have more innings of pitching. It's not really about just the league having better pitchers. You'll be excited to know there are no graphs. There aren't graphs. Instead, what you'll do is present this triangle picture that I've been drawing on the board. Okay. I have an example. It is editable, so you can copy it, click on it, and edit it. Okay. This is the original example for this data. Okay. What about beta? There is a little bit of debate about beta. On the one hand, I like having beta because then I could compare the strength of the original C and this, but right now, well, I could here, but I can't compare anything from league to budget because they're different scales. But since we're trying to show what happens here, since these are in the same scale, most people say don't do beta because you're standardizing, but you're standardizing on different DVs. Because this one has Y as a DV and this one has M as the DV. And so the standardization doesn't make sense because they're different IVs and DV combinations. So most people stick with B. I have seen beta presented before, but generally people do B. If you wanted to do beta, it's just LM beta of your model within the quant sci library. All right. So it's actually, I would say mediation is actually a little easier than the hierarchical one we did last time. It just has more steps. I have an example write-up, and it has an example table that you can make as well.